Good afternoon, everyone, and welcome to the webinar entitled The Basics of Perimeter Fire Containment. My name is Christina Larkin, and I will be one of your moderators, along with John Zalepka, who is our Training and Development Manager. We would like to take a moment to review some housekeeping items before we start. All attendees will be muted during the webinar. We will be disabling the chat feature during this session. Questions can be sent in the Q&A section. We will be gathering your questions during the webinar and will hold a question and answer discussion at the end. We will be reporting AIA credit for those of you who attend at least 75% of the live webinar. If you have an AIA number and did not give it upon registration, please send it to webinars@stifirestop.com. If you are not a member of AIA, STI will be sending certificates of attendance for you to self-report to whatever agency you wish. We will also be sending a recording to all who registered. Please allow 7 to 10 business days for the generation of certificates and recording.
Thank you, Christina. Our presenter today is Michael Zanatelli, STI's facade and curtain wall specialist for the Western US and Canada. The Basics of Perimeter Fire Containment was designed to eliminate the confusion associated with the different aspects of perimeter fire barrier systems. This course will help us to understand the role and value of tested systems in today's complex curtain wall configurations. The fire stop and curtain wall industry in particular change on an almost daily basis, so Mike will discuss the codes and standards which are essential in the design phase in order to eliminate costly changes, delays, and compromised life safety requirements during construction. Please welcome Mike Zanatelli. Mike, the floor is yours.
Good afternoon. I would like to welcome you to today's Perimeter Fire Containment training. We appreciate you taking the time out of your day today, and thank you for the opportunity to speak with you. My name is Mike Zanatelli, and I'm part of the curtain wall team at STI. I currently handle the western region of the US and Western Canada. Later in the program, I will introduce the other members of the curtain wall team and discuss the services that STI and our team provides. Before we get into today's presentation, let's get past some quick formalities. This is an AIA registered course with one CEU available, and as Christina said, we can take care of that towards the end of the program. And also, this presentation is subject to copyright protection. The use of any images or content may not be used without written consent from STI Firestop. Today's presentation has been developed to assist you in understanding the requirements of perimeter fire barrier systems and how to avoid costly headaches and delays during design and construction. As we progress through the presentation, please feel free to submit your questions in the Q&A window. And most of the questions we'll answer towards the end, but there may be some that John and Christina can answer directly as I'm doing my presentation. As the construction of high-rise buildings continue to reach higher and higher throughout the world, perimeter fire or curtain wall fires continue to be an increasing problem. The recent fire in London has changed many of the codes worldwide and has made an impact on how people protect high-rise structures. Unfortunately, we continue to have fires on a regular basis. Some examples of high-rise fires with injuries, deaths, and property loss in 2020 include fires in Hawaii, Chicago, Los Angeles, New York City, and most recently in South Korea just a few months ago. Our discussion topics today will cover the following: a brief introduction on what curtain walls are, the evolution of code consistency, the importance of testing for perimeter fire barrier systems, which also will include a detailed review of the ASTM E2307 and the ISMA, and also understanding how to read tested assemblies, designing and installing for success, which includes key design and installation points for non-backpan aluminum frame systems, meeting the next set of challenges, a brief update on what we've been working on at STI, and then we'll have plenty of time for question and answer at the end. So what are curtain walls? Curtain walls are non-structural, non-fire rated perimeter walls, most commonly found in commercial, multi-story, or high-rise construction. They serve as an exterior skin that provides protection from the elements and helps provide a comfortable environment inside the building. Curtain walls can have many different appearances, but its main characteristics are narrowly spaced vertical and horizontal aluminum framing with glass, stone, metal, or composite panels. What does non-structural mean? Curtain walls are rigidly attached to the floor slab with an anchor system. So the curtain wall facade does not carry any dead load weight from the building other than its own dead load weight. The curtain wall transfers wind and gravity loads to the main building structure through connections at floor or columns of the building. Since the curtain wall is non-structural, it can be made of lightweight material like aluminum, which will reduce construction costs. Let's review the components of a traditional aluminum framed curtain wall system. First, you have the anchor system, which will be located either on top of the slab, the edge of slab, or completely under the slab. The curtain wall framing that consists of vertical mullions and horizontal transoms. The spandrel areas, which can be glass, metal, stone, or composite panels, and last is the vision glass area. Let's briefly discuss the evolution of code consistency. A good starting point is always to have a solid understanding of the code requirements. In the perimeter fire barrier world, we use the 2012 IBC as the version of the code that outlines the requirements of the new ASTM standard, which has eliminated much of the confusion of earlier code versions. The great news is the codes have finally established consistency with the adoption of the 2015 and 2018 IBC codes, as well as multiple state codes being revised. The 2012 code adopted specific language to outline the requirements and further eliminate confusion that future versions have built upon. As you know, the protection of voids is mandatory in all building codes, with the IBC addressing specific ASTM E2307 requirements. Section 715.4 addresses the voids created at the intersection of a non-rated exterior curtain wall and a rated floor or roof slab to prevent the interior spread of fires. These voids are to be sealed with an approved system to prevent the interior spread of fire. Systems must be securely installed, i.e. mechanically fastened in place. Systems must be tested in accordance with ASTM E2307, which we will cover in detail shortly, and they must provide an F rating equal to that of the floor or roof deck. Canada has also adopted the ASTM E2307 requirements into the 2018 S115 Canadian Code. The adoption of the ASTM E2307 requirement into the Canadian Building Code was delayed due to the pandemic, but it's scheduled to formally happen this year. This slide is taken from the 2018 S115 code. As you can see, ASTM E2307 is referenced in Section 9 as the standard method for perimeter fire barriers using the intermediate scale multi-story test apparatus, or as it is commonly known as the ISMA. In the next section, we will discuss the ASTM E2307 standard and the ISMA in detail. Let's get into our discussion on the ASTM E2307 standard and the ISMA and understanding how to navigate through a tested assembly. So what is ASTM E2307? ASTM E2307 is the standard test method for determining fire resistance of perimeter fire barrier systems using the ISMA. This is a very severe and difficult test to pass, and it differs in three critical ways from how standard construction joints are tested. These assemblies are tested between a rated floor or roof barrier and a non-rated exterior curtain wall assembly. This test method measures the performance of the perimeter fire barrier system and its ability to maintain a seal to prevent fire spread during the deflection and deformation of the exterior wall assembly. The curtain wall and joint are burned from below and also from the exterior to mimic how high-rise fires perform. Compartmentation is a key component to fire life safety. This is the process of dividing a building space into small units by constructing rated boxes to limit the spread of fire, toxic smoke, and gases to their point of origin. This allows occupants to get out and first responders to get in. Obviously, this is critical in fire life safety, but in curtain wall, structural integrity is just as critical. Because if the wall comes off the building, the joint will go with it. So we must protect the key components of a non-rated curtain wall system as long as possible. The fire will attack any voids at the floor line on the interior side while breaking out the vision glass on the floor below. The fire will also attack the framing system, which is typically constructed of aluminum. Again, if we don't protect the critical components of the non-rated curtain wall properly, the entire wall will fail. Let's take a look at some pictures of a project that we were involved with. If you look at the spandrel panels, you can see exactly where the most severe area where the fire was. On the right, you can see the panels starting to melt. On the left, you can see the panels gone and only the spandrel insulation is left. Moving further to the left, you can see the section of the spandrel and safing insulation at the floor slab that has been held in place by the stiff back angle. On the floor where the fire broke out, you can see the failure of the wall system, which is exactly what will happen. The aluminum framing, vision glass, and spandrel panel are completely gone. But on the floor above, the anchor and aluminum framing are all intact and protected. The perimeter fire barrier system did its job. It is important to note exactly how critical and severe the ASTM E2307 test standard is for perimeter fire barrier systems by looking at the ASTM E119 time temperature curve used during the test. Note the melting points of rigid foam panels at 300 degrees Fahrenheit, spray foam 390 degrees Fahrenheit, zinc will melt at 790 degrees Fahrenheit, and aluminum alloys begin to soften at 865 degrees Fahrenheit and will melt entirely at 1220 degrees Fahrenheit. So if we are running a 2307 test at a third-party lab that consists of aluminum framing, we will start to lose the lower framing members just 9 minutes into the test. And we're just starting a critical stage of protection that must last for another hour and 51 minutes. Let's take a look at the impact of the 2307 test and the ISMA on a recent test that we conducted. On the left, you can see the multi-story wall prior to the start of the test. On the right, you can see the very start of the test with the internal burner just lit. Here you can see the internal burner gaining intensity very quickly from two different angles. And here you can see the internal burner really cranking around 5 minutes into the test. Next, the external window burner is lit. The test begins to ramp up quickly, and the wall is now under attack from fire on the interior side and the exterior side. Here you can see the intensity of the test has progressed significantly, and we start to see flames as high as 14 feet. At this point, we start to see critical components of the wall start to show fatigue under the temperatures and pressure of the time temperature curve. As we talked about earlier, roughly 9 minutes into the test, you can see the lower horizontal framing member, or transom, starting to melt, deflect, and twist. Moments later, you can see the lower framing of the wall giving way as the flames eat through the wall system. To document the extreme heat and pressure of the full-scale ASTM E2307 test on the ISMA, you can see vision glass used in the design has melted and is running down the exterior of the wall assembly. This is not a common occurrence as the glass generally breaks or shatters during the test, but this does demonstrate the extreme temperatures the wall is subjected to. Here you can see the impact of the ASTM E2307 standard at the end of the test. Critical components of the wall system have been lost and the assembly is glowing red hot. Here you can see the impact of the vertical framing system at the floor line and the anchor system in direct correlation to the location of the exterior window burner. It is important to note that the wall will twist, warp, and come apart at the floor slab. The key is to maintain integrity of the wall system at the anchor points at the floor slab and maintain integrity of the wall system above the floor slab. Once we have a successful test per the ASTM E2307 test requirements, a test is published. Both Intertek and UL test to the same ASTM E2307 standard, but there are unique aspects to both labs. UL has the ISMA configuration for backband designs, anchors tested in designs, and realistic movement requirements. Intertek has testing for all vision glass, hybrid window walls, and wider mullion spacing. We use the best aspects of both labs in our tested designs to give us the ability to produce real-world perimeter fire barrier systems. Once you have that successful test, you are given a system number. Each lab has an alphanumeric numbering system. It's pretty simple to understand how these systems are labeled once you've read through a few. I'll quickly break down what everything means in a UL system, and then we'll take a look at an Intertek system. For perimeter fire containment testing, the first two alpha characters are CW, which stands for curtain wall, which means this assembly was tested per ASTM E2307 on the ISMA. The second set of alpha characters will be an S or a D, referencing either a static or dynamic design. Please note that in perimeter fire barrier systems, a static system is completely acceptable. Most people are familiar with the static and dynamic movement of head of wall joints, where the dynamic movement is either compression or extension. In a perimeter fire barrier system, the movement is a 5% vertical shear only. The numeric components address the gap width in the system and the test number in that series. The first number references the width of the gap between the curtain wall and the edge of slab. So the 0 series are for joints up to 2 inches, the 1000 series are for joints up to 6 inches, and the 2000 series are for joints up to 12 inches. The last three numeric components list the test number in the series. So this assembly is the 41st test run for a perimeter fire barrier system for a joint width of a max 6 inches as tested per ASTM E2307 on the ISMA. One more thing to note, the last three digits are a sequential proprietary numbering system that is unique to the manufacturer who passed that test. At Intertek, system STI BPF 12004 is broken down as follows. So STI is obviously the company identifier, which would be us. BPF stands for Barrier Perimeter Fire, tested per ASTM E2307 requirements. 120 means 120 minutes, which is a 2-hour F rating. And 04 will be the fourth system in this particular grouping. Having a strong pedigree of tested systems to choose from is critical in the design or installation phase of perimeter fire containment systems. The value of these tested systems are always recognized and respected by architects and inspectors. It will limit project delays by eliminating any concerns. It will save money by keeping the project on or ahead of schedule and limit liability and exposure. And as we have discussed, tested designs will obviously work in real fire conditions. Let's continue to our next section, which is designing for success. In this section, we will discuss the key design and installation points for non-backband aluminum frame designs and wrap this section up with some of the challenges that we consistently face and how to address them. In this section, we'll discuss the requirements of the components of tested designs, including the following: why we use light gauge metal for spandrel insulation attachment, the proper orientation of mineral wool in the safing slot, the role of mullion covers, and lastly, the role of the tested fire stop spray. Every tested system for aluminum frame designs require 5 basic features. The spandrel insulation is mechanically fastened to the frame or the steel backpan. A stiffener or reinforcing member installed behind the spandrel insulation to maintain the compression of the safing in the slot or void area. The mineral wool in the safing slot or void is installed with the grains running vertically and to the required compression listed in the system. Mullion covers installed above and below the floor slab where required, and the safing shelf installed on the backpan designed per specific system requirements. And installation of the tested fire stop coating as showed within the system. So why do we use light gauge metal, hat channel, or insulation hangers in the tested designs? Light gauge metal is required for the following reasons: to keep the spandrel insulation in place, to maintain the integrity of the wall system in a fire, to meet the 715.4 code requirements of securely installed, and it is required in all UL and Intertech tested designs. Here you can see the role of the light gauge continuous angle that is fastened to the framing, and the spandrel insulation is secured to the angle with drywall screws and fender washers or cuphead weld pins per the system requirements. Note the melting of the vertical mullions and the bowing of the frame system at the bottom where the transom is burned out. There are many tested options, including a continuous angle. Hat channel is another option, and various types of insulation hangers. The development of high-performance insulation hanger systems are changing the way spandrel insulation is installed in the shop and in the field. These new systems provide substantial labor savings. The designs have major advantages over traditional methods, including the fewest number of screws installed into the framing system, or in many cases, no screws at all. This allows proper internal drainage within the framing system, and these systems excel in wall systems where there are steel liners inside the mullion or blast-proof walls with steel reinforced mullions. Light gauge metal is also used to support the compression requirements of the mineral wool in the void or safing slot. Please note the spandrel insulation is not fastened to the angle. It simply sits behind the spandrel insulation. You can see the galvanized angle on the left and the hat channel used on the right. They are generally located about 2 inches from the top of the floor slab. Here you can see the stiffener keeping compression of the mineral wool in the void, even as the curtain wall framing comes apart below the floor slab during a fire. The proper orientation and compression of the mineral wool in the void or safing slot is often misunderstood. On the left, you can see the proper method with the grains running vertically along the slab, and on the right, you can see the incorrect method with the grains running horizontally. You can see the two images on the right, how the grains running horizontally do not compress and buckle, which will cause fatigue to the joint system. The images on the left, you can see the mineral wool is turned with the grains running vertically. The mineral wool compresses like an accordion, allowing the mineral wool to rebound against itself to maintain proper compression. Please note that when the mineral wool is installed correctly, there are no additional supports or old-style insulation Z-clips needed to support the safing. Our current systems are tested up to a max 10-inch wide gap. Let's take a few moments to discuss mullion covers. Traditionally, mullion covers have been used to provide a bridge between the spandrel insulation over the exposed mullions. They are designed to stop the transmission of heat through the mullion to the knee wall. The mullion covers are cut from foil-faced spandrel insulation and installed above and below the floor when necessary and through the safing slot. There have been many recent advancements in the requirements for mullion covers. Many of today's high-performance tested designs only require mullion covers below the slab. In some cases, mullion covers are not required for the fire test. They can simply be added for thermal requirements when needed. It is always recommended to refer back to the tested design for specifics on mullion cover requirements. Let's go over the role of the fire stop coating. This is the final step in a compliant design that acts as a glue to keep the system intact on the top side of the floor. Most importantly, it stops the propagation of smoke and fire through the mineral wool in the safing slot. Stopping smoke will save lives when you have a compliant system, but we continue to see damaged or incorrect installations quite often. This could be due to spray damage because of exposure to water before it cured, hard brittle compounds that crack once cured, incorrect caulking that have washed out due to water exposure, untested solutions that simply stuffing pieces of mineral wool into the void. As you know, 70% of all fire-related deaths are due to toxic smoke and gases. Most occupants have already perished from smoke inhalation by the time the flames reach them on the upper floors. So installing a code compliance system is obviously critical. Our last section is meeting the next set of challenges from curtain wall consultants, architects, and code officials. As we discussed earlier, anchor protection is a very critical component of any perimeter fire barrier system. Remember, if the anchor fails, the entire wall goes with it. UL has just adopted testing requirements in the XHDG guide for all manufacturers that require dead load anchors exposed to direct fire must be protected. These anchors must be protected for the hourly rating of the floor slab. UL has adopted a new category, the XHDI guide, that clearly defines what is an acceptable level of anchor protection. This is a mandatory requirement of curtain wall consultants and designers, and the codes are adopting language to incorporate a consistent requirement. Here you can see two examples of protecting the components of a top of slab anchor on the left and a face of slab anchor on the right. In some cases, we can allow the fist slider assembly to extend below the safing a max 2 inches without additional protection, which we have in our UL system CWD 1044 and CWD 1045. While other designs fully encapsulate the anchor system, allowing the mineral wool to extend below the floor slab by a max of 2 inches, as detailed in our UL system CWD 1050. In conditions where the anchor plate or assembly is fully exposed on the underside of the slab, specific solutions were needed to be created to pass the rigorous test standard. Here you can see an anchor protection product that is simply shot into the deck from below, providing complete protection of that anchor. UL has also started to publish specific tests incorporating these new requirements. For example, our UL system CWD 1032 is the only tested design able to treat a fully exposed under slab anchor system. One quick note before we proceed. Because the glazers have all types of anchor systems, our curtain wall team spend the majority of our time assisting the curtain wall consultants, architects, glazers, and fire stop contractors in the proper protection of the anchor systems to ensure that the entire wall stays intact in the event of a fire. Unfortunately, we are brought in too late on some projects, and due to a variety of reasons, it can be difficult to address the anchors properly. So regardless of whether you're a general contractor, architect, glazer, or fire stop contractor, please get us involved early so collectively we can address these anchors properly. Another issue that has become a concern for code officials, architects, and curtain wall consultants comes from the use of newer framing systems. Here you can see an example of what's called a single chicken head design. This design creates an opening in the face of the frame system at the stack joint. This will allow smoke, toxic gases, and flames to travel inside the mullion vertically to the floors above. The proper way to address this is to use a specific type of mullion plug that has been tested in these conditions. An important point to note is that the mullion plug would have to be shop installed during the fabrication of the wall units, because once the units are set, there is very limited access to the vertical mullions. Before we end this section, I just want to emphasize, just like anchor protection, our curtain wall team spends a lot of time addressing these situations also. I know there's a colleague of mine on the webinar who was involved on a project that had this exact condition. It was not addressed prior to the units being set, and unfortunately, all the vertical mullions at the stack joint on the entire project had to be cut open and addressed after the fact. So again, please feel free to get our team involved as early as possible, and we can properly address these conditions for you. So this concludes our AIA section of the presentation. We're excited to give you a quick update on what STI has been working on. We want you to know that you're not alone. STI is your global fire stop solution partner. STI owns 60% of the perimeter fire barrier systems tested at UL and many more at Intertech. But having the greatest number of systems isn't enough. As we talked about, it's all about real-world testing. STI has developed complete tested solutions for backpan, non-backpan, all vision glass, and hybrid window wall designs. But that still isn't enough for today's modern and complex projects. We also offer complete tested coverage for precast, EIFS, and GFRC designs. STI has also invested in the development and testing of the industry's most successful products for perimeter fire containment, including water-based and an all-weather high-performance fire stop spray for perimeter containment. The quick clip system that has quickly become the standard procedure for both shop and field installed spandrel insulation, and the industry's first ASTM E2307 tested solution for hybrid window walls, crossover window walls, and vertical notch curtain wall systems using our window wall gasket. As we looked at earlier, STI has developed many tested designs for top of slab and face of slab anchor protection. We have also developed the first and only tested solution for 2 hours on a completely exposed under slab anchor system using our CP100 product. In addition, we have worked closely with our glazing and consultant partners to develop the industry's first UL tested solution for sealing inside the mullions. This is a two-part foam incorporating an intumescent technology that will expand 11 to 14 times for complete protection. It requires no wet sealant or flammable foam in a can. Simply install in the shop and set the units. It has a leakage rating of less than 1 CFM, an NRC of 0.75, 0 VOCs, and obviously it's a UL listed product. The mullion plugs are custom cut for projects, and we will work directly with the design team early on to ensure a seamless install in the fabrication shop. STI's commitment to supporting our customers is never ending. We offer unmatched technical support from our engineering services group with over 250 years of combined experience through 2 U.S. offices, 6 days a week. Our goal is a 24-hour turnaround time on engineering judgments and immediate technical support. Our curtain wall team works daily with our engineering group. As I mentioned in the beginning, I cover the Western US and Western Canada. Aaron Alterman covers the central portion of the US and into central Canada. And Eric LaCroix, who is the director of the curtain wall team, covers the eastern portion of the US and eastern Canada. We have over 45 years of experience between us. And as we have discussed, our role is to assist in the design of perimeter fire barrier systems with architects, curtain wall consultants, glazers, and fire stop contractors. Once the project has broken ground, we will then assist with the local STI personnel to help deliver a successful project. To make our partners' lives easier, we developed what we call a handbook of solutions that focuses on the most cutting-edge systems. It's easy to work with, so you don't have to search through 160 tested designs on our website. It is broken down by wall types, insulation attachment types, and anchor types. The handbook contains backpan, non-backpan, all vision glass, short panel, hybrid window wall, and anchor protection designs. Please feel free to drop me an email, and I'm happy to send you a copy. And with that, here's my contact information. And with the time left, I'd like to open up the floor for any questions from anybody.
All right, Mike, thank you very much. Right now, we only have one question on the board, so hopefully we have everyone thinking what questions they might want to type in there. So go ahead and do that while I tell you about this great giveaway that we have here. Mike just put up on the screen a QR code. So if you can grab your phones right now while you're thinking of all those great questions you want to ask, and just hit that with your camera, that'll take you over to LinkedIn. We'd love some feedback from Mike. Let us know how we've done, and we'll pick a couple of winners and send you out one of the bags that you see up there. We have some backpacks, some pretty cool tool bags. And yeah, so Christina, you want to get us started on the question?
Sure. We have one question that came in. What about buildings that have double facade to generate an internal balcony? Internal gaps should be sealed, of course. This is a two-part question. So if you want to answer that one first, and then.
Well, is Eric on the line? Because I know he's worked with a double facade just recently. That may be related to one of his projects.
Yeah, let me just unmute him. There you go.
Hi, everyone. Can you hear me okay, Christina?
Yep, you're good.
Hi, guys. Hi, Michael. Thanks for the question. Regarding double skins, to be honest with you, it's a bit of a lengthy conversation because there are a lot of variables, but we are very well-versed in double skins. In fact, we've just designed with one of our architectural partners. We've supported with several new designs on some upcoming projects in New York City that require double skins, and we can discuss with the specifics if the gentleman or the person would like to contact Michael or myself directly. What we can do is take a look at your specific design and we can address it there.
Okay, I'll actually email, type out your email and Mike's email to him so that he has it, so he can contact you guys further.
Great.
All right, let's see, I'll see, can a backpan system be used on a glass spandrel panel? Anyone?
What was the question? Can a backpan be used on a glass spandrel panel?
Yeah, exactly.
Well, they're typically two different conditions. Again, if you want to send that information over to me with what your particular project has, I'm happy to take a look at it. Because typically you'll have those are two different conditions that may be being confused there.
Sure. So JR, thank you for the question. Please send in maybe a drawing or a little bit more on your specific condition, and we'll help you out there. Christina, you got another one?
Sure. Are there any approved contractors you work with and recommend that are experts with your systems?
Yeah, that's a bit of a loaded question, but yeah, there are lots of contractors throughout the country and into Canada that use our products and that we would consider very proficient in the perimeter fire containment world. If there are specific projects that you're looking for someone to bid a job, again, if you want to send us a quick note, we can discuss that offline and get you some contacts in that particular area if that works.
All right. Question came in about Intertech static versus dynamic joints. UL, it's pretty easy. They have an S or a D. Is there anything in the Intertech system number, I guess, is the question, where it would say whether it's dynamic?
Eric, you there?
Yes, hi. Can you still hear me?
Yeah.
Hi, yeah, normally, no. Normally it's in the system description. If you look at the system, it will reference movement as a description in the design. Like if you look at for example, like our design 120-03 or 120-07, if you just look in the heading, it will have a description for movement if the system is tested for that. UL, you're correct. UL lists the systems per movement, will be either CWS or a CWD.
Yeah, and as you're going through your design work, just feel free to send us some information and we can guide you quickly into the right systems that you'll use, so you don't have to search through all the systems that we have.
All right, Christine, you want to grab that next one?
Sure. Can you discuss the custom mole fire stopping a bit more?
The mullion plug?
I'm assuming so, yes.
Okay, I thought I heard mole. Yeah, so that would be something like when you had that design at the stack joint where there's an opening there. So there's an area where for smoke and flames and sound can actually transmit through there. So what we do way ahead of time is we'll communicate and help design with the glazer the actual size of their mullions, and we'll custom cut our mullion plug to fit inside the mullions, whether it's a vertical application or whether it's a horizontal application. So that product is now listed in several UL systems of ours. So it's becoming a lot more popular, like we talked about before. And again, if there are specific projects that you have, feel free to drop us a line and we're happy to guide you in the right direction.
Mike, can I just jump in on that for 1 second?
Sure.
Sure. We get a lot of questions about noise and vibration as well. And as Mike said, when we developed this originally for the internal, transfer of smoke vertically and eventually fire through these frame systems, we quickly realized that these items perform tremendously for sound coefficient ratings. And in fact, as Michael mentioned, we have a 0.75 in our national coefficient NRC rating. So what that means is that this plug installed in the units, and they're installed as the units are being set in the field, it actually will reduce up to 75% of the vertical noise transmission. So in areas like we get asked a lot, like say for resort areas, or say New York City or Las Vegas, for example, where you have a lot of mixed use, you have nightclubs on the bottom level. A lot of times there's a lot of issues with noise transmission through the vertical framing, into the hotel rooms above. So this item has actually been developed in conjunction to provide that type of seal as well. So as Michael said, if you have any questions at all, if you're dealing with a frame system that is a single chicken head design that has an opening in the face of the frame, or you've got transmission issues or coefficient issues or vibration issues, please feel free to call us and get us in touch, and we'll be more than happy to help you out.
So a good question that just came in. When is the best time to get the curtain wall team involved in the process?
That's an easy answer. It's never too early. There was a couple of jobs we worked on last week that won't break ground until 3 years from now. So regardless, general contractor, glazer, architect, fire stop contractor, don't be afraid to give us a call at any time. We're happy to help out any way we can. And honestly, even if it's a competitive situation, we'll help you out. It's not a problem.
Well, thanks, Mike. Do dynamic systems require a different anchoring scheme due to the movement?
No, they won't require a different anchor. The anchoring, like I've mentioned before, anchors, because there's tons and tons of anchors out there that we encounter all the time. But movement is not going to be an issue because it's a 5% shear movement. So the anchor is not going to matter.
Are there any tested designs for open corners or transitions from one system to the next?
Currently, there are not because UL doesn't have the capability to do that. When you have something on the corner, some of our systems, like our quick clip system, we do have some corner systems that we can use a different type of product. But the actual corner itself, that's typically going to be an engineering judgment situation. So again, that's something you can bring to us early on, and we can help you out with that.
Great, Mike, thanks. Are there new UL numbers in use for the added SNS mullion plugs at the single chicken heads? I just wanted to say single chicken heads.
A lot of people do. Yeah, they're in certain UL systems. And again, if you want us to send them over, we can do that for you, no problem at all.
All right. It looks like we've answered all of the questions there. So with that, Christina, you just want to just wrap it up real quick? Just let everybody know. I think a couple people came on late about the housekeeping.
Yeah, if you missed it, we'll be reporting that AIA credit for you who attended at least 75% of the live webinar. If you're not a member of AIA, we'll also be sending certificates of attendance and a recording as well to all who registered. So just give us 7 to 10 business days for that, and we'll send it out to you.
All right. Before I let you go, I just want to say, Carlos, thank you for the question. Yes, we do have webinars related to telecom and electrical systems. They are on our Firestop University. So when you get that email or this recording from Christina, same process, you'll be able to find those recordings there as well. So feel free. There's probably about 12 or 13 different accredited courses up there. So please have at it. And we thank you very much for your time, and stay safe out there, everyone.
Thank you very much.
Thanks, Mike. Thanks, Eric. Thanks, Christina.